AgroMatrix. AgroMatrix aims to explore how we can promote a food-centric lifestyle at a neighbourhood level. According to the Global Food Index by United Nations, the UK is ranked 17th of 113, below many neighbouring countries. The Industrial Revolution brought about the rapid growth of transportation, and food could be transported in from outside the city in a constant stream. The function of food in cities began to be decentralised. The footprint mapping shows the cropland's quality into 4 classes. A food system consists of production, consumption, and recycling, and a food network is a connection of all of this. Treats the city as a supermarket. Our site selection was carried out by gathering and analysing numerous statistics, which assisted the project in identifying the neighbourhood issue. Principal component analysis, a dimensionality reduction algorithm, is used to reduce the data into set components to make them more manageable for further analysis. The Normalized Difference Plant Index, NDVI, is calculated by using remote sensing data and synthesizing the bands of Landsat 8. Furthermore, we simulate the rainflow, slope, and aspect by utilizing DEM data as parameters for site selection. Suitability analysis is a process for evaluating and weighing the criteria required for scientific site selection using machine learning. We used food-related data and environment-related data to find an optional site location. Finally, the 2 analysis methods helped us conclude that Poplar falls in the high food desert and low-income neighbourhoods category and should be the site for our proposal. This section demonstrates a machine learning approach for site analysis and space identification. Semantic and instance segmentation is a fundamental strategy for solving computer vision issues, since it allows for the discrimination and segmentation of distinct elements in large-scale images and videos. To determine the place available for on-ground and roof, we divide our planned region into 900 patches designated for satellite image segmentation. To determine the place available for vertical, we examined 4 viewpoints of the street and 4 kinds based on the area of building facade by segmentating 1,600 photos. The outcome indicates 4 types of vertical strategy. A pentagon model is constructed to examine the space percentages. Regarding this, we project the space to the function, production, consumption, and recycling to identify locations for our food system. Finally, we combine the results with the food photos from social media as crowdsourcing data to locate the situation and predict the demand. We use unmanned aerial vehicles to record videos of the main crossings and then send them to PixelLib and OpenCV for deep learning with the street images. After all the results were overlaid, we finalized our design area according to convenience, energy, and comfort. We begin by identifying the ideal locations for growing food in our master plan. Starting with the vertical farms, we find locations based on environmental data and areas for food production, after identifying the structures using an evolutionary algorithm that maximizes the quality of sunshine. For our food network, we created a new algorithm, which helps us define production, consumption, and recycling points on our site, and later allows the growth of different food crops in production points. The next stage was to learn about the crops that could be cultivated in the designated production area. To that end, an evolutionary multi-objective optimization and analytic engine was developed that considers various crop development statistics such as temperature, daylight hour, humidity, and living space volume needs. The app's concept is to promote urban agriculture at a community level for community engagement. The app's primary goal is to locate places where food may be grown and markets where food can be purchased. Using external parameters like sunlight hours, humidity, and crop lifetime, our AgroMatrix algorithm helps the user identify the best crop to plant on a parcel of land. Users can select any parcel of land in the area and explore the crop type. Another feature of the app will be selecting crops based on the seasons. For our suggested solution, a food network was included in the city. We created a network of lines using the Woolly algorithm, using integration points, points distant from the shadow, and production keeps. The discrete design tool uses the Wool algorithm to shape the aggregation based on the connection rules. We proposed different modules to create an interplay of a mini interconnected food system. We then employed discrete design as a design tool to create a network of links between our production, consumption, and recycling modules to propose a food-orientated neighbourhood development. Growing food is one of the best ways to reconnect with nature and the community. Food colour adds a vibrant environment where people can connect back to food at all levels of the food system. Building local food systems, contributing to food security, stimulating economic growth, boosting social integration, and improving urban biodiversity and environmental health are all benefits of urban agriculture for individuals and communities that have been considered for the design on AgroMatrix. This is your neighbourhood, our neighbourhood.